Well, welcome to the last panel of the day, but this is the Bragging About Massachusetts panel. These are some incredible entrepreneurial clean tech companies that are all started and based here in Massachusetts. You don't have to get too confusing about what they make. Fusion, hydrogen, batteries, we're really at the core of the energy transition with this panel. So I wanted to give each person a chance to introduce themselves and tell us a little about your company and kind of what the goal is there. Ally, do you want to start?
Sure. Nice to meet everyone. As Aaron said, my name is Ally. I'm Senior Vice President of Corporate Development at Commonwealth Fusion Systems. So we are commercializing fusion energy. Some of you may or may not be familiar with it, but it's basically the process of stars that we're trying to bring here on Earth. It's a source of clean, firm, dispatchable, safe, citable anywhere type of power. We are taking an approach. We spun out of MIT in 2018. We're now about 6 years old. We're the largest private fusion company in the world. We're the third largest organization in the world, next to the state of China and the UK. Just under 1,000 people. We've raised $2 billion to date. And we're taking an approach of taking kind of as much established science basis, standing on the shoulders of the national labs and universities around the world, and pairing it with a revolutionary type of magnet technology that we manufacture in-house. We're currently building a pilot plant about an hour west of Boston in Devens, which is a familiar place for all of us, we're neighbors, that ultimately will demonstrate commercially relevant net energy in a scalable modular form factor. And from there, we'll build our commercial power plant. We're targeting early 2030s.
Thank you. Derek?
Sure. Derek Warnick. I'm the CFO and co-founder at Electric Hydrogen. We manufacture the world's most powerful and efficient hydrogen electrolyzer, basically taking in large amounts of renewable energy to split water into hydrogen and oxygen, where the hydrogen can be used as a carbon-free substitute for natural gas and many industrial processes. Our technology is based on a 100 megawatt architecture, so we're happy to provide folks electrolyzers. If you want 100, 200, 300, we can do that. Nothing in the middle, any color you want as long as it's black. And we are very, very focused on the cost, the levelized cost of hydrogen. That was the impetus of founding the business. We kind of spun this out. I used to be at Breakthrough Energy Ventures. One of my co-founders was at BEV as well. He was the CTO who took First Solar public and had been working on hydrogen at BEV. And we really established this business understanding that the fundamental economics, unsubsidized, were going to have to get there over the long term in order for this to be successful. So if you can split water at a lower cost than pumping dinosaurs out of the ground, you win. If not, you lose. It's really that simple. And we also, we've got our Gigafactory up in Devens, Massachusetts. It's a wonderful place if you need a lot of power. And we're over 300 people now. We've raised only $800 million. Usually that's a lot when I'm sitting next to Ally. And yeah, thanks for having me.
Professor Wang is here with helping co-found two different companies in the battery tech space, and also representing one of our great local academic institutions, Worcester Polytech, which is producing all kinds of related green tech students. Tell us a little about your two companies and what you're up to.
Sure, yeah. Again, my name is Yan, and my full-time job is a professor. So I'm still teaching, research, and advise students. And all my professional career is electrochemistry. So I have been working on electrochemistry-based technology for all my professional career. I work on the fuel cell before, nickel metal hydride batteries, lithium-ion batteries. My lab is still working on different battery projects, battery materials, manufacture, recycling, design. I also work on some other electrochemistry-based projects. For example, one of my recently funded by ARPA-E is how to produce convert iron oxide to iron directly using electrochemistry method. It's a green iron or green steel. And I also work on recycling solar panel, recycling fuel cell, electrolyzer. That's what I do in the university as a professor. I co-founded two companies. One is Iceland Elements. They are doing lithium battery recycling. And when I start working on the recycling project, that's back 2011. So at that time, people are still trying to push battery batteries, battery materials. Many people actually laugh at me. They say, Yan, how can you get those batteries to be recycled? And one thing convinced me is like, because I truly believe the EV industry, I believe sooner or later, and the auto industry will convert to EV. Recycling is just a matter of time. So that's how like I started research. Like I'm probably maybe one of the earliest person in the nation to start working on the lithium battery recycling seriously. So the company has pretty successful in the last few years. They raised like probably over $1 billion. The government also gave like $500 million from the BO funding. They have a commercial operation, commercial plant in Georgia, and they also are building a $1 billion plant in Kentucky. And to be fully transparent, like I stepped down as a board member for SN Elements last September after they closed the Series D. And but now I split my time between WPI as a professor and also AM Batteries. AM Batteries is another company I'm working on. So like so AM Batteries, we develop dry or solvent-free electrode manufacture technology. And if you guys know how the battery electrodes are being manufactured, almost 50% of energy drying and do the solvent recovery. That's a big pain for industry. So back 2013, I started working on the technology. Initially, it's also from fundamental research, university research, and I even co-founded this company like 2016. But since then, we don't have much activity. The reason is I do not feel the timing is there yet. So later, after Tesla acquired Maxwell, and in 2020, Tesla announced dry battery electrodes for their cell manufacturer. I feel the timing is here, so then I start talking to investors. Luckily, we got some investment from TDK Ventures and other venture firm. That's how we started. I was the interim CEO for 2 years. Later, I found like I cannot be the CEO. Then I recruited Lee, is also here as the CEO. He's much better than me. So like, so then we start from there. So far, we raised $60 million. And there's lots of customer interest from big tier 1 cell manufacturers and car manufacturers. So we have maybe 55 people right now. So like I hope soon we'll be another unicorn. Thank you.
Thank you for those introductions. You heard each person talk about how much money they've raised. It's a large sum. We're going to get into that. But first, I wanted to focus a little on geography. Why are there companies in the Boston area? How is it beneficial? Boston has an incredible talent pool, but also very high cost of living, high cost of electricity. Tell us a little each maybe about why the companies are here and how you see the strengths and weaknesses of the local clean tech ecosystem.
Do you want me to go first?
Sure.
Yeah, so I think for us, and I think this is true for a lot of things that are inherently spinning out of something that was invented or researched in a university, I think it was really important from the beginning. We spun out of research at MIT, and we still have a very strong partnership with MIT. In fact, we're the largest private sponsor of research at MIT, more than like Google, even as a startup. And I think like when you're working on something that's inherently novel in that way, proximity to the resources, but also the people, the expertise is really important when you're kind of pulling that out and trying to incubate it. So I think that's something that played a really important part to us, like not just when we first got out of the university, but as we started thinking about where we were going to site our headquarters, proximity to that was a key piece. I think as we start to grow, there are different pros and cons. There's challenges with as we start to build in different types of workforce populations, there's cost of living, et cetera. But I also think we managed to find kind of a nice sweet spot for now in Devens, which is close enough to Boston, but also far enough away where there's slightly better kind of cost of living and different types of workforce, as well as some things like fast permitting, et cetera. But I think ultimately, a key piece, I think for me too, is it's really cool to have so many peer companies here. I mean, Derek has talked to me before, like we've traded notes, he's helped me on thinking about strategy. I think in general, this industry is very community oriented and really willing to help each other. And I think that actually goes a long ways, particularly when you're just getting started.
Devens used to be Fort Devens. It was a military base that the state has repurposed into this clean tech hub. Derek, you're also there. Tell me a little about your Massachusetts story.
Absolutely. Yeah, Devens is a unique place. We sound like an infomercial for it, but when we're looking for where we're going to put our factory, it was power. That was the number one thing that we needed. Also, if you're trying to make the sun on Earth, you need a lot of power. And so that was a really key driver for us. Why we ended up in Massachusetts from the very beginning, we were very intentional about kind of co-founding the business, based in Boston, in the Boston area, and then in San Francisco Bay Area. For us, it was about the workforce that we needed for the first couple hundred people that we're going to hire. That early on, that was a lot of PhDs, a lot of kind of core science when we were in the lab trying to see, can we make this thing work? Okay, we can make it work. Then it was hardcore engineering, which was, Tesla and SpaceX folks were, okay, we can make it work. Can we make it bigger? Can we make it more efficient? And now we're at the stage of the business where we're trying to say, how can we get the volume of our manufacturing to increase? How can we increase yield? And so the workforce that we have in Massachusetts and in the Bay Area is well suited for that, but we are now transitioning where we're looking at line operators and manufacturing technicians, of which surprisingly, central Massachusetts, as an example, is not all that expensive in the scheme of things. It is more expensive than someplace like Texas or Oklahoma, but you get a lot of value when you have your first manufacturing line, as an example, that you don't have to get on a plane in order to get your engineers that have designed a product and you have a manufacturing engineer that's designed a process, and then someone gets on a Zoom call with you and says, it's not really working like it's supposed to. You're supposed to get on a plane and then spend a week of your life in order to solve something that might take 15 minutes if you were there every day. And so to be able to get the team that actually did the basic research, and we've moved many of that team up 45 minutes from here, but to have that connectivity has been very important. And I think that starts with kind of the great universities in the Massachusetts area, but then the ecosystem that has built around that. I think the Boston area and the Bay Area both have that. You can get the best people in the world that are focused on these problems, and you can get them to transition from one great startup to another. And then you get to compare notes with other great companies that are trying to do things. And there's a reason that events like this are held in this area, because you get people who are worthwhile to talk to, know what they're doing, to really focus on the same problem at the same time.
Yan, now the two companies you're involved with did start here, but also have built large factories, not at Fort Devens, but in totally other states in the South and everything. Tell me a little about the process. Why did you start here, and what do you see to put things in other places?
Yeah, because initially, because as a small startup company, we want to work with a university, because there's lots of resources like a university can supply. Like, for example, when we recycle the materials, after recycling, we need to generate loads of new materials. For batteries, we need to do the full characterization. Like we want to make sure the materials is as good or even better than the commercial materials. That means we need lots of analytic tools. Like by the startup company, probably we don't have money to buy all the tools. That's why normally we leverage WPI resource a lot initially. That's why initially we start here for SN elements. But after the company grows to a certain stage, like recycling is like a special business, because the spent batteries is called class 9 hazardous materials. Transportation for those materials can be expensive. So normally for recycling companies or recycling business, they want to close to where the spent batteries and also where the battery manufacturers. And right now in the US, all over we talk about recycling spent lithium batteries, but in reality, most of the input materials is still manufactured scrap. So for example, when the battery manufacturer, they produce maybe 10 gigawatt hour capacity for the new batteries. Normally, even for very mature plant, they produce 5 to 10% of scrap materials. That's lots of materials. For new battery companies, initially probably 75%, then 50%, 25%. Eventually, after maybe 3 years, they can go to 5 to 10%. That's lots of materials. So that's why normally you see the big recycling plant, they want to be close to the manufacturer plant for those giga battery plant. And I think also there's a reason those some state, they offer more incentives for such business. That's the reason why the Ascent Elements initially start from Worcester, then we move to Westboro. They also have a site in Novi, Michigan, but they're big they're big facilities. One is in Georgia, the other one is in Kentucky.
And that was because of state incentive.
Yeah.
We'll continue with you on that side. We talked about all the money that's been raised, but the environment for raising money for startups like yours and the other people on the panel has changed dramatically in the last few years. It's good that people raised big rounds when they could, but what is the outlook now? What is the feeling now when you are thinking about fundraising?
My feeling is this year is very hard. I talked to some of our investors, even because investors, they also need to raise money. Even for them, it's hard, because especially for battery industry, because in the past, maybe a few years, many battery companies, they raise billions of dollars, they raise lots of money, they cannot deliver. You see some company, they raise many billions, they have small capacity. So typically for Asian battery manufacturers, they need less than $100 million for 1 gigawatt hour capacity. But you see lots of US, European battery manufacturers, they raise billions of dollars, they probably have less than 1 gigawatt hour capacity. And for startup companies, if you just need investor money, you cannot deliver what you promised. I think eventually it will be very, very hard to raise money. I do feel this year for battery industry, it's not easy to raise money.
Now, Derek, you have these I'm not pronouncing it correctly, electrolyzers.
That's right.
And we heard in the earlier panel about certain kinds of other financing maybe that can be done for projects like that. Tell me a little about the financing that you've raised, and is there anything in terms of innovation on that score?
Sure. So we are an OEM. We produce the electrolyzer systems themselves. We are not a owner of projects, at least not at this time. It's something we're looking at a little bit more seriously. I am a recovering developer myself. I did power development in Texas for a number of years. So when we think about the challenges that we are trying to solve with financing, that is both at the corporate level on our end, and then our customers' challenges about how they get their projects financed, which starts with making sure that our technology is reliable and something that usually that a bank or other kind of debt provider can get behind. If you're looking for equity, there are people that will take greater risk for greater return. Banks usually don't do that. So on the project level, what we need to do is really deliver a product that our customers have got sound data, they can understand this works. That's why we built on our balance sheet, we have a 10 megawatt facility operating in San Jose, California. It's a terrible place to build anything. It's very, very expensive. The power is insane. It's like $250 a megawatt hour for PG&E. But it is a wonderful place if you are trying to get customers or investors to come by. 25 minutes from SFO is a great location to try to get someone to see that. So that's what we've really done on the customer side for helping to get our projects financed. At the corporate level, we're big believers in not just relying on kind of traditional venture capital early on in our company's life cycle. We did plenty of early stage venture raising, but then we also tried to incorporate early on a smaller, what started with venture debt facilities, of which we didn't draw on early. And then we started to layer in things like, as we get larger, like equipment finance. So our facility up in Devens, nearly all of the equipment in that facility was financed through equipment finance. So a lender providing capital that is specifically collateralized against the equipment itself, which means that that's not debt on my balance sheet. That is not sitting senior to my equity investors. If we were to go, belly up, I hope that doesn't happen, but they'll go and they'll take the industrial laser back or whatnot to repay the balance on the loan. And then more recently, we did a large equity financing last year, but then we also coupled in a $100 million credit facility from HSBC, JP Morgan, others, that both serves the purpose of adding more capital for our needs, but capital that is well suited for investing in assets that help make us successful, instead of investing in people and salaries. Those are what equity dollars make a lot of sense to do. And it also serves the purpose of providing the first steps toward bankability, if you were. If a large bank like HSBC or JP Morgan is willing to give you money at the corporate level and believes that that's a sound way that they'll recover their investment and make a very small return, that starts to provide some of the credibility necessary for financing the first project, of which we are in construction of a 100 megawatt project now down in Texas. And that one was not project financed. The first of a kind, as you've heard, it's very rare to get there all the way at once. But we are big believers in kind of using different varieties of capital in order to best meet the needs at the time.
And how was that one done then?
So that first project, that is a customer that's got a deep balance sheet, and then there's a provider that's putting in equity in that. But there's no debt on that deal until it gets up and running and people can see that it's working. We've taken that first step with the banks, but you won't get bank debt on your first deal ever.
Some creativity.
Yeah, that's right.
Now, Ally, what you're building is almost like a whole world apart from what these guys are talking about. I mean, fusion is not yet proven yet. So you've raised a lot of money. How hard was it to convince investors to buy in, and what's the outlook?
I think, certainly in context of like the market is obviously different right now than it was in 2021. I think there were definitely people participating in climate tech in 2021 that maybe weren't there for the long term, but there's certainly still a lot of people that are, and I think increasingly so. I mean, I think there's no shying away from the fact that we're capital intensive and also require long time horizons. On the other side of it, though, is like the largest market in human history. It's like $1 out of $12 is spent on energy in the markets that fusion can address. And I think of GDP, I think that for us, finding people that see both the strategic interest and the financial interest of fusion has been key. Fusion has its own challenges with it is inherently hard to understand and hard to parse through. When you read about what's happening in the news, it's not always obvious what milestone matters and whatnot. I think I have a PhD level science education. I work at a fusion company and I still have a hard time sometimes figuring out what some of the news means. A lot of what we try to do is build relationships for a long time before we ever are raising capital from those people, and try and teach people what it is that we're doing, tell them what we plan to do, build a reputation of doing what we say we will and a track record of execution. I think that's been key to our success of bringing in more capital over time. I think we've tried to help establish what key milestones matter, not just for us, but for the industry. But I think we increasingly, and it kind of not unlike what Derek was saying and also what was on the panel before, we require people to be flexible. So we don't really fit normal size buckets of capital. So we are, large ticket size, but not necessarily time to revenue in the next, 2-3 years. So structurally that's challenging on one side. I think technical risk from some people's perception, valuations that are not, starting to not be in the venture realm. And so I think where we've had the most success is finding capital providers that have kind of the ability to be flexible in how they kind of package and think about working across the buckets. And that's been really important to us. And I think will increasingly be so over time.
I think you've raised a couple of really interesting issues for investors there. The earlier panel was talking about how not every company maybe should go public. Maybe I'll start in the middle, Derek, with you. What's sort of the vision that you give investors as what's ultimately going to happen? What are the exit ideas for your company?
That's a great question. I think that anytime you're out there raising money, you have to have a credible path toward liquidity for the investors on a time horizon with an exit of a size that they're excited about. And if you can't check those boxes, they're not going to invest. That answer that is right for your business isn't going to be right for every investor. So I think that's important. I think from our perspective, we're on this panel. We're a unicorn, right? So that means that the number of options that we have for liquidity for an exit is much smaller than if you are a smaller business. If you are a business that's hoping to one day be worth $50 or $100 million, there's a lot of corporates and strategics and potential acquirers out there in the world. As you start to build a larger business that's trying to have a more global impact, that universe becomes much smaller. So the public markets are one that could make a lot of sense. I think that's probably the way that this will end up for us, or a very large kind of industrial conglomerate, of which there are enough to kind of leave their options open. I think what's important for us is that we're not trying to get there too soon. Two of my co-founders were both CTO for Solar at different times. And reflecting on that, like being in a public company is not fun. Running a business on a quarterly basis as CFO is, that's not fun unless you're big enough where you've got smooth earnings and you're talking about, X pennies per share. The type of businesses that we all run now are very lumpy, and the big prize is yet to occur in the future. So I'd say that likely entering the public markets is what will make the most sense, but it's not going to be next year, and it's going to be when it makes sense for our existing investors, for the new investors that will come in from the public market so they can understand the business that we run. And most importantly, it's going to happen when it's right for our business, which will mean that we've reached a large enough size and scale where we've got predictability that can be measured on a quarterly basis and not, on an average basis over a couple of years.
Cautionary tale, I spent the morning writing about a quantum computing startup in Boston that ceased operation because they went public by merging with a SPAC and didn't have much they could show to the public markets. And the way all the complicated SPAC maneuvering worked out was that they had a call on capital that they couldn't meet, and now they've ceased operation. So it's certainly something to think about. Professor Wang, what for batteries, is that something that could end up as a public company, or how does it look?
Yeah, in the last few years, actually quite a few battery companies that they went for public through SPAC. But if you see most of them, I would say 95 of them, they are $1 per share or less than $1 per share. The fundamental reason is those companies, they don't make money. So they don't have revenue to support their valuation. I think both asset elements AM batteries, we are trying to avoid. So I work very closely with AM batteries right now. So AM batteries, we want to make money early. So even today, if another company asks small samples, we charge people. So that's how we make money from small to big. And we want to break even early. We want to make money early. So hopefully, soon we don't need investor money. We can be a self-sustained company.
I'll jump in there just a little bit to say, I think you'll agree. It'll be a little while before you make money, but we've taken a bit of a different approach on our end to be very focused on not chasing profits early on our end. And battery market's a very different one. But on our end, I think there's some lessons learned on the solar side from German, feed-in tariffs, back in the early 2000s, that the market that exists today and trying to capture profit in the market that exists today may be at the detriment of getting a product that can actually perform in the final market that really makes a lot more sense. So we are going to continue to raise capital for quite some time to make sure that we can get down the cost curve and be able to compete with fossil fuel straight up. Being able to be profitable in a heavily subsidized global market today when it's this big is very different than building the product for the huge market in the future. And sometimes that does take a lot more capital in the near term.
Ally, what's the outlook you give to investors?
We definitely don't promise being a public company anytime soon. But I think to Derek's point, I think we think about what are milestones that would maybe have some sort of appetite. And it's one is demonstrating for the first time on Earth a commercially relevant net energy. That's in the 2027 timeframe. But that's 5 years roughly before we turn on our very first commercial power plant. And the concept of being a public company under quarterly scrutiny while you're building a 5-year project doesn't sound like the best path. I think one thing that we try to think about sometimes is like on a first principles basis, like why be a public company? And on the one is that we have investors that want to have some form of liquidity, and the other is on the basis that like there's more access to capital there. It's not inherently clear on both sides that being a public company is the way you get those two things. We've seen examples, companies like SpaceX that have stayed private for a longer time, but certainly have done things like secondaries in order to cycle through different time horizons of investors. I think those early investors are not upset about the fact that that company is still private. They've certainly made a lot of money. I think at the same time, we're seeing, for something like Fusion, a lot of times sovereigns, strategic capital, and high net worth family offices are definitely groups that we're targeting right now. And I think that's a pile of capital that's growing on the private side. I think in general for us, we're trying to position ourselves so that in the future we have the opportunity to do so, but probably not realistically until we turn on the first electrons on the grid, which would be in the early 2030s. But we certainly want to be primed so that if an opportunity presents itself earlier, that we can kind of have the right compliance capabilities to do so. I will say there's some people, and I sort of totally understand the point of view, often have made the comment that, like, is it right or morally right for Fusion to be private? Like, should it be accessible, once it's proven, should it be accessible to a broader set of public investors? And I think that's a really interesting point. We're not really sure how to put that into our calculus, but it's something that we actually hear fairly often.
It will be, if it really comes together, it will be one of the most disruptive things in the history of our economy. So we'll see. My next question is about a risk that I'm hearing people outside the United States looking in at the United States are thinking about, and that's political risk. We have an election coming up in November where it almost seems like a binary outcome where one candidate is still very supportive of clean technologies and thinking about climate change, and the other candidate is much closer to the fossil fuel industry, and who knows what would happen with all the incentives and laws that we've already passed on that. I'm curious, as you're going about your business, is this something that you can start hedging for, thinking about the political risk, or do you feel like you're far enough along in the business that it won't affect you dramatically? I don't know, Ally, do you
I think for us, we've done a lot over the past 6 years to build bipartisan support. I think one of the things is, and I think this is probably true for everyone here, is like fusion is a good investment, like irrespective of climate change. Like it is like a paradigm shifting type of energy source. And from an energy security standpoint, it makes a big impact as well. And so like there's a lot of things that resonate about it that have nothing to do whether people agree about kind of climate change or what market mechanisms need to be supported. With that said, I think we are trying to kind of right now do kind of a scenario analysis of like how might we change our activities in the next bit of time in one scenario versus the other. But I think we have seen a lot of bipartisan support both sides.
Professor Wang, the battery industry and EVs are getting a lot of government support. How do you think about what might change?
So again, let's go back to fundamentals. I personally truly believe in the EV industry, and we already see some other countries. For example, in China, right now, more than 50% of new cars is EVs. People like EVs there. We also see some other countries, they have a very high percentage of EVs. If any car companies, they don't switch, I think eventually they will fail. I'm a big believer for the EV industry.
Derek, do you guys benefit from any of the current subsidies?
First, I want to thank you for throwing politics in here right at the end of the day. That's great. Never a hot button at all. But I would say that there certainly are kind of differing climate policies between the two candidates. I think two main perspectives on this. One, the markets that we're focused on are global. So the U.S. is obviously an important market for anyone doing anything. but the markets that we're focused on are global. So the results of the US election has relatively no impact on what Europe or Australia or the Middle East is doing. And Asia is more of a demand center for us versus a location for supply. Japan, Singapore, Korea are probably going to be net importers of hydrogen or hydrogen-derived commodities. As we look at the U.S. itself, I think the Inflation Reduction Act is obviously kind of the tip of everyone's tongue now, and I think that when you look at the provisions that are most applicable to hydrogen, that's 45V. There's a whole alphabet soup of different provisions in the bill that help all sorts of different companies. But 45V is for hydrogen. That's the hydrogen production tax credit. I think what's interesting about the analysis that's been done on the Inflation Reduction Act so far is the dollars, at least announced investment dollars, are skewing like 65% toward Republican-leaning districts versus Democrat-leaning districts. So I think that part's very wise to create that bipartisan support, because at the end of the day, this is infrastructure. These are real assets. You're putting steel in the ground. And when you're thinking about the hydrogen industry, there's a lot of overlap between the classic hydrocarbon industry itself. This is an opportunity for people that exist in the global businesses to clean up their act, but at the same time make money. So as long as we can provide something that is economically compelling, I think what we're hearing is there's probably very little risk. It's also not sexy to tweet about hydrogen. This is probably not going to be the thing that elections are won or lost on. And there's a lot of capital to being deployed behind the scenes, which sits on both sides of the aisle. So probably pretty resilient to this, but it's going to be interesting to see what happens either way.
I guess interesting is one word for it. Any questions out there in the audience for this panel? Back here.
Yeah, I think I still think about Derek's comment a few minutes ago when you mentioned that your company is not looking to become profitable early, but try to keep raising and building and try to get to the same cost parity as possible. Can you explain a little bit more about that strategy? How does that work?
Absolutely. So to clarify, it's not that we're seeking not to become profitable. It is that we are very focused on long-term profitability over short-term profitability. So what that means is that we price our systems so that we have a profit on each sale that we make, but we're not trying to make a business that's cash flow positive. We aren't trying to cease taking in new investment. What we really want to target is essentially providing the customer with the absolute lowest price that we can possibly charge them, so that we can get as much volume as possible over the next 5 to 10 years. Because solar is, the first solar playbook is similar to what we run at Electric Hydrogen, and that's to focus on large volumes early to get down the cost curve. Because as stated on kind of previous panels today, the Chinese are certainly very, very focused on cost in hydrogen in many industries, and global players are definitely going to be there. If there's a market to be had, someone is going to get down the cost curve. For us, we would much rather have 10 times the volume of sales for the same amount of profit versus one extremely profitable sale, because it will allow us to hit the volumes necessary to bring that cost down, so that this is the type of infrastructure asset like Emmanuel was talking about earlier, where someone can say, oh, I'll take a 7% return on that. You've got to be very mature, both in your deployment numbers, getting down your cost curve, but also you need to have a lot of instances of your product being deployed so people have trust and belief in its reliability.
Well, thank you guys for a great panel. I think I heard a few things about Massachusetts and Boston that kind of surprised me as really positive attributes, whether it's surprisingly affordable manufacturing or a network of similar companies to comfort you, maybe. I guess I would ask what you guys think is the paramount attribute of Boston, Mass, that would make or retain its status as the preeminent climate hub?
I have a couple thoughts. I know it has big ambitions to grow kind of its climate hub. I think it needs to decide what it wants to be, because I don't think it can be everything. Like ultimately, we're in the business of we're going to be building factories, we're going to be building assets. It's not like there's going to be a true headquarters where like everything we do is here. You know, we're right now citing where our first commercial power plant will be. It's not going to be in Massachusetts. And it's not because we didn't want it to be, but it's just not, you know, realistic and feasible based on our requirements. And like ultimately we want to be a global company and we're going to need the muscle of like building these all over the place. And so I almost feel like, you know, I hear people talk about it of like, how do we make Boston, you know, equivalent of what it is in biotech to climate tech, but like there's differences in like the way the biotech industry is self-organized, where like, you know, there's much more acquisitions from like the larger to the smaller, and like really what Boston's really great at is like pulling ideas out of labs, out of universities, proving it out, and then like developing it in partnership. And it's sort of this vicious feedback loop that's really, really productive. I feel like Boston needs to like decide and own what it is. I personally think something that it's really good at is the like early like shepherding and nurturing and helping. Like we have so many amazing universities that develop amazing new technologies and like help pull them out of the lab into market and help do that kind of, you know, Derek talked a lot about like the early like interactions between taking it from like, does it work in the lab? Okay, does it work at scale? And how do you keep doing that feedback loop? But ultimately, I think it can't go through the full life cycle of climate tech either, I don't think. And so I personally think it kind of needs to like find its true identity.
I will say that a lot of the early internet work was done here in Boston at Lincoln Labs and at BB&N, and the big internet companies are not here and the biggest data centers are not here. So we'll see whether we can maintain some of that strength here or whether it goes all over. But thanks so much to the panelists. Let's give them a big hand.